Good morning, students. In this class, we are going to discuss about the next concept in the S block elements, that is chemical properties of alkali metals. Now, in my last class, we have already discussed about the physical properties of the alkali metals. In this class, we are going to discuss about the chemical properties of the alkali metals. Now, for this one, first I will take the rough paper. Now, alkali metals means which group? First group. Group 1 elements are called as what? Alkali metals. What are the elements? Lithium, sodium, potassium, rubidium, cesium, and here francium is the radioactive element in the group 1. Now, all are having how many valence electrons? Only one valence electron. If you remove this valence electron, then what will be the oxidation number or charge? +1. Means general oxidation number or valence of this alkali metals is +1. Means always the charge, just think the simple way, charge on the alkali metals is +1. If I write M plus in the reaction, just to think that M mean alkali metals. M means what? Alkali metal. That is, it may be lithium, it may be sodium, it may be potassium, it may be rubidium, it may be cesium, etc. Right? M means what? Alkali metal. Now, in the chemical properties, few reactions are there. In those reactions, I will take M plus. M plus means what? M means what? Alkali metal. M plus means what? Charge. Right? Li plus, Na plus, K plus, etc. In this way, I am going to use. Now, here. What are the chemical properties we are going to discuss here is, first we are going to discuss about the reaction of alkali metals with air. Now, second chemical property we are going to discuss is reaction with water, reaction of alkali metal with water. Third chemical property or reaction is a reaction of alkali metal with dihydrogen, that is H2. Means how the alkali metals are reacting with the H2, that we are going to study in the third one. Next, fourth one is reaction with halogens. Halogens means 17th group elements: chlorine, fluorine, bromine, iodine. Now, next chemical reaction we are going to discuss is fifth one, a reducing nature of alkali metals. Reducing nature of alkali metals. And the last chemical property we are going to discuss is reaction with ammonia. Reaction with ammonia. Ammonia formula is NH3. Means how the alkali metals react with the NH3, that we are going to study in the sixth chemical property of the alkali metals. Now, these six we want to discuss in the chemical properties of the alkali metals. First one is reaction with air, second one is reaction with water, third one is reaction with dihydrogen, reaction with halogens, next fifth one is reducing nature of alkali metals, and the last one is reaction with ammonia. One by one we will discuss. Right? Now, first one we will start here. First one, that is reaction with air, we will start. Air. Here, for this one, I will take one rough paper. Alkali metals, that is lithium, sodium, potassium, rubidium, cesium, right? Alkali metals. Here, charge on alkali metals is +1. It is fixed. Air means oxygen, O2. Air means oxygen. Oxidation state of oxygen may be -2, maybe -1, maybe -1/2. Right? If the oxidation state of each oxygen atom, this is -2 for only one oxygen atom, -1 for only one oxygen atom, this is -1/2 for only one oxygen atom. If the oxidation state of oxygen is -2, that is called monoxide. That is called as what? Monoxide. If the oxidation state of oxygen is -1, that is called peroxide. that is called as what? Peroxide. If the oxidation state of oxygen in the compound is -1/2, then it is called superoxide. Superoxide. Just remember, when the oxidation state of oxygen is -2, that is called monoxide. When the oxidation state of oxygen is -1, that is called peroxide. When the oxidation state of oxygen is -1/2, that is called superoxide. Right? But the oxidation state of alkali metal is fixed. Alkali metal is fixed, that is +1 only. It is not changes. It is not changes. Now we will see here few reactions we have to write. Alkali metals reacts with air to form monoxide, sometimes peroxide, sometimes superoxides. Three types of oxides are formed. It can form monoxide, it can form peroxide, it can form superoxide. That depends upon the alkali metal. That alkali metal used is lithium, sodium, potassium, rubidium, cesium. Right. Now we will see if alkali metal, that is lithium, reacts with the oxygen, it will form the lithium oxide, lithium monoxide. Here for balancing I am taking 4 atoms of lithium. Here 2 are 4 2 oxygen atoms. Right, this is called lithium monoxide. The name for this compound is lithium monoxide. Lithium monoxide. Monoxide because oxidation state of or oxidation number of oxygen in this compound is -2, therefore it is called lithium monoxide. Now in case if this alkali metals, right, that is sodium, if the alkali metal, that is sodium, I will use another pen here, green pen. If this alkali metal sodium reacts with the oxygen, it will form the corresponding oxide, Na2O2. For balancing I am taking 2 here. 2 sodium atoms when reacts with the air, that is oxygen, to form the sodium oxide. But here oxidation state of oxygen is -1. Oxidation state of oxygen is how much here? -1. Therefore it is called as what? Sodium peroxide. Sodium peroxide means, just remember, when sodium reacts with the oxygen, it forms what? Sodium peroxide. Next, whereas I am taking M here. M means, here I will take M. M means it may be potassium, rubidium, cesium. M means what? May be potassium, rubidium, cesium. When it reacts with the oxygen, it will form the MO2. It will form what? MO2. Now, if you check the oxidation state of oxygen, here it is -1/2. If you calculate, already we have know how to calculate the oxidation number. In the redox reaction, we have studied one particular concept, that is oxidation number. Right, here oxygen's oxidation number is -1/2, therefore it is called as what? Superoxide. Superoxide we have studied already. Now here, if the oxidation number or oxidation state of oxygen is -2, then it is called monoxide. When the oxidation number of oxygen is -1, then it is called peroxide. If the oxidation number of oxygen is -1/2, then it is called as what? Superoxide. Here for lithium, it is oxidation number is -2, therefore it is lithium monoxide. For sodium, the oxidation number of the oxygen in this compound is -1, therefore it is sodium peroxide. Whereas when potassium, rubidium, cesium reacts with the oxygen in this compound, the oxidation state of oxygen is -1/2, therefore it is called superoxide. If it is potassium, potassium superoxide. If it is rubidium, rubidium superoxide. monoxide. If it is cesium, cesium superoxide. That depends upon the oxidation state of the oxygen. If the oxygen's oxidation state is -2, monoxide, -1, peroxide, -1/2, superoxide. Now just remember, don't think that sodium forms only sodium peroxide, potassium forms or rubidium forms or cesium forms only superoxide. It's not in this way. This lithium forms only monoxide. It cannot form the peroxide, superoxide, whereas this sodium can form monoxide as well as peroxide, whereas this potassium, rubidium, cesium can form monoxide, peroxide, superoxide. Now that is only I am writing here lithium. Here lithium forms only monoxide, whereas sodium forms monoxide and peroxide, monoxide as well as peroxide, whereas these three, what are those? These three, potassium, rubidium, cesium, these three can form both monoxide, peroxide and also superoxides. This is the main point, right? Now this is the reaction with the air. Over. Next we will go for the second one. This one over, first one. Second one we will go for the reaction with the water. For this one I am using another paper. Now second one is reaction with water. Write down second one heading, reaction with water. Reaction with water. Now already we have studied that. Now second one we are going to discuss, that is reaction with water. Means how the alkali metals are reacting with the water and what are the products formed in the reaction. Now we will see. For example, this is the rough paper I want to use. For example, this one is the beaker which is filled with the water. Beaker which is filled with the water. In this one, in this beaker, if I am adding any alkali metal, now the beaker contains what? Alkali metal plus water, to form. Here water means H2O is there. H2O can also be written as OH minus and H plus, right? This OH minus reacts with the alkali metals to form corresponding hydroxide. Alkali metal and OH, that will be there, corresponding hydroxide, and this H converts into the H2 gas. H2 gas means when alkali metals reacts with the water, they form corresponding hydroxide. If it is sodium, sodium hydroxide. If the alkali metal is potassium, potassium hydroxide. If it is cesium, cesium hydroxide. In this way, corresponding hydroxide is formed and it will releases the H2 gas. That is only I am writing here. Now when alkali metal, Am means what? Alkali metal reacts with the water, that is H2O, they form corresponding hydroxides and releases the H2 gas. Now this is the explanation. How to write the explanation? When alkali metals reacts with the water to form corresponding hydroxides and releases the dihydrogen gas. Now I will write the reaction here. Now what is the reaction is, just to check here. Alkali metal, I am taking M here. M means what? Alkali metal. When it reacts with the water, that is H2O, it will form MOH. M charge is +1, OH charge is -1. Therefore, the correct formula is MOH, and it will release which gas? Hydrogen gas, H2 gas. Now, it is not balanced here, right? Total number of hydrogen here 3 are there, here 2 are there. For balancing, I am multiplying with here 2, here also 2, here it is. Now it is 2 MOH. Now it is balanced. Just check here, left side 2 alkali metal atoms are there, here also 2, here 4 hydrogens are there, here 2 hydrogens, 4, and how many oxygen atoms are there? 2 oxygen atoms are there. Now if M is lithium, if the alkali metal is lithium, then the corresponding hydroxide is lithium hydroxide. If M is sodium, then the corresponding hydroxide is sodium hydroxide. If M is potassium, then the corresponding hydroxide is potassium hydroxide. If it is rubidium, rubidium hydroxide. If it is cesium, cesium hydroxide. M, that depends upon the M. right? This is the reaction with water. How to explain? When alkali metals reacts with water to form corresponding hydroxide and releases the hydrogen gas. That is this reaction you have to write. Now next we will go for the third one, second one over. Third one is reaction with dihydrogen. Reaction with dihydrogen. Third one I want to write, that is reaction with dihydrogen. Now dihydrogen means what? H2. Now how the alkali metals react with the H2, that we will see in the hydrogen chapter only. We have studied the hydrides. First group elements when reacts with the dihydrogen, they form the ionic hydrides, that we have studied. A same reaction I'm going to write here. Now when this alkali metals, that is AM alkali metals, reacts with the dihydrogen, they forms the corresponding hydrides. If it is lithium hydride. If it is potassium hydride. If it is sodium hydride. But you have to remember, in hydrides the hydrogen oxidation state is -1, because alkali metals are active metals that we have studied already. When the dihydrogen reacts with the active metals, they form the ionic hydrides or simply hydrides, where the hydrogen's oxidation number is -1, that we have discussed already. Now we will write the reactions. Now remember, these hydrides are ionic in nature, or these are called as what? Ionic hydrides. Now we will see the reactions. First example. In place of alkali metal, take lithium, sodium, potassium. That is only the reaction. Now just check here. First example I want to write, when 2 atoms of lithium reacts with dihydrogen. Right here the temperature required is 1073 Kelvin temperature. It will form the lithium hydride. Here oxidation number of lithium is +1 and the hydrogen is -1. Similarly I will take the second example, that is sodium. When this sodium react with the dihydrogen, here required temperature is 673 Kelvin temperature. It will form sodium hydride, that is 2NaH. Right, here also sodium oxidation number is +1 and hydrogen oxidation number is -1. Now next we will go for the third one. Third one is, just check here, third reaction is potassium. When the potassium reacts with the dihydrogen, here also 2 only, right, it will form potassium hydride. Here also potassium oxidation number is +1 and hydrogen oxidation number is -1. Now I will write that here. These are very important for the 1 marks. He will give KH. What is the oxidation number of hydrogen in the potassium hydride? Your answer should be -1 in this way, right, etc. For other you can write easily. Same reactions. When alkali metals reacts with the dihydrogen, they form the corresponding hydrides, which are ionic in nature. In all these hydrides, the oxidation number of hydrogen is -1. This is also over. Reaction with dihydrogen also over. Next we will go for the fourth one, that is reaction with halogens. Fourth one. Here I will write fourth one. By using green pen I am writing fourth one. Reaction with halogens. Here next one is reaction with halogens. We will discuss. Halogens means which group? Halogens means group of 17. What are the elements? Chlorine, fluorine, bromine, iodine. Actual order is fluorine, chlorine, bromine, iodine, etc. are called as what? Halogens. Now we will see how the alkali metals react with the chlorine, fluorine, bromine, iodine, that is halogens. Now for this one I will take the another paper here. Now halogen 17th group. What is the oxidation number? -1. Don't forget, -1 is the oxidation number for the halogens. Now I will write the reactions here. Now just check. When alkali metals, Am means alkali metals, reacts with the halogens. Halogens always exist as the diatomic molecules, that is X2. X may be Cl, Br, that is Cl2, Br2, F2, etc. Now it will form the corresponding halide, that is corresponding halide. If it is sodium, sodium halide. If it is potassium, potassium halide, that is corresponding halides. Now we will see the examples. We will see what? Examples. Just check here. I am taking few examples. Now here, examples. First one, general example I will read. If the alkali metal is M, reacts with halogen X2, it will form 2MX, that is called corresponding halide. Corresponding halide. Here it is. If 2M, that is alkali metal, reacts with the halogen X2, it will form 2MX, that is MX means what? Corresponding halide. Right. Now we will see the particular examples. First example I want to discuss, that is now just check here. When lithium reacts with the chlorine, it will form lithium chloride. For balance I am taking 2 here, 2 here. Right. Lithium is the alkali metal, chlorine is the halogens. It will form the corresponding halide, that is lithium chloride, Cl chloride. Halide is chloride. Now second, for example, sodium 2Na plus Cl2 gives rise to 2NaCl. This is called sodium chloride, that is alkali metal halide. That is alkali metal is sodium and the halide is chloride. In this way the reaction will take place, etc. You may take halide, that is X. X may be Cl, Br, fluorine, iodine, etc. Right. Alkali metal you may take lithium, sodium, potassium, rubidium, cesium, etc. But don't take francium because it is a radioactive. This is the reaction with the halogens. How to explain this one? When alkali metals reacts with the halogens to form the corresponding halides. Example, when lithium reacts with the chlorine to form lithium chloride. When sodium reacts with the chlorine, it will form sodium chloride, etc. Next we will go for the fifth one. 4 over reaction with halogens over. Fifth one is which one? Reducing nature of alkali metals. Fifth one. Reducing nature of alkali metals. We will discuss now how alkali metals will reduce as the other agent. Now for this one I will write 3 reactions first. Metal, M means what? Metal, that is in solid state. If you heat for a long time, it converts into the gaseous state. Now solid converting into the gaseous state. Solid converting into which state? Gaseous state. Now when the solid converts into the gaseous state, right, that is called as what? Sublimation. That is called as what? Sublimation. And the energy required is called sublimation enthalpy. Sublimation enthalpy. Here solid converts into the gas, sublimation enthalpy. Now here another one. When the metal which is present in the gaseous state, if you remove the one of the electron, then it will be M plus and it is in aqueous state. In a which state? Aqueous state. You have removed how many electrons? 1 electrons. The amount of energy required to remove the one of the electron from the gaseous atom, that is called as what? Ionization. Loss of electron or removal of electron, that is called as what? Which enthalpy? Ionization enthalpy. Ionization enthalpy. That is only I am writing here. Ionization enthalpy. Now here 1 electron is removed, that I will write with red pen. Just check here. one electron is removed. One electron is removed means it is undergoing into the oxidation reaction, right? A loss of electron, which reaction it is? Oxidation reaction. The one which itself undergoes into the oxidation reaction, that is called as what? Reducing agent. Means here the alkali metals are acting as the reducing agents. Just to check here, when this metal which is present in the solid state, if it is heated, it will convert into the gaseous state. When this metal is present in the gaseous state, if you remove the electron, means the loss of electron from the metal, that is called which reaction? Oxidation. Already we know that oxidizing agent, what is meant by oxidizing agent? The one itself undergoes into the reduction. Now, what is meant by reducing agent definition? The one which undergoes into the oxidation. The one which undergoes into the oxidation is called as what? Reducing agent. Means here the metal which is present in the gaseous state, the alkali metal which is present in the gaseous state is acting as a reducing agent. Reducing agent. That is the name, reducing nature of alkali metals. Also, when this M plus which is present in the aqueous state, M plus, right, which is present in the aqueous state, if it reacts with the water, it will form the M plus with OH minus ions. That is called, right, when the ions dissolved in large amount of water, which enthalpy it is? Hydration enthalpy. Hydration enthalpy. Now, just to concentrate on the second reaction, here loss of electron is taking place, that is oxidation. Here alkali metal is undergoing into oxidation, means it is a reducing agent. Over. This is the fifth one. Next, last one is a reaction with the ammonia. Sixth one is a reaction of alkali metals with ammonia. Ammonia formula is NH3. Now we will see. Here ammonia formula is NH3. Alkali metals. Here I am taking general reaction just to check here. Alkali metal I am taking as M. M means what? Alkali metal. M means what? Alkali metal. Now, when this alkali metal M reacts with ammonia, X plus Y times. X means any number 1, 2, 3, etc. Y also any number 1, 2, 3, etc. Sometimes X and Y are equal, sometimes X and Y are different. Right? X plus Y times of NH3 gives rise to here, just check, two products are formed. MNH3X times. MNH3 which times? X times. X times of NH3 are reacting with the M. Now M loses one electron. Then what will be the oxidation number of this complex? Plus 1. Plus 1. Here the charge on the MNH3X is plus 1, because if this M loses one electron, then what will be the oxidation number or charge on this complex? Plus 1. Plus 1. Right. Now another product formed is Y times of NH3 are there, and M is losing one electron. That one electron will be taken here by the NH3 Y times. How many times? Y times. And what will be the charge? Minus 1. What will be the charge? Minus 1. This is the product formed. These two are the product formed. Just remember, when alkali metal, that is M, alkali metal M reacts with the X plus Y times of NH3. X plus Y times of NH3. Now X times of NH3 reacts with the M. X times of NH3 reacts with the M to form MNH3X. MNH3X. Here M, if it loses one electron, then what will be the oxidation number? Plus 1. Means this complex, what is the charge? Plus 1. Plus 1. And here M is losing one electron. One electron. And here how many times of NH3 are left? Y times of NH3 are left. That one electron combines with NH3 Y times. Y times, and what will be the charge? Minus 1. Minus 1. This MNH3, this compound, that is, once again I will write MNH3X times having plus 1 charge. It is blue in color. What is the color of this one? Blue. Also I am writing with blue color only, correct? Blue in color. And paramagnetic. Paramagnetic means it is weakly attracted towards the magnetic field, or unpaired electrons are there. Therefore, it is paramagnetic. Paramagnetic. Again, it undergoes into the reaction after some times. After some times, again this compound, that is blue paramagnetic compound, this compound complex undergoes into the reaction, just like this type of reaction here. MNH3X plus 1 charge is there, it undergoes into reaction and it will give amine, that is MNH2X times, right, plus 1, right. Here this is called amine. Amine means NH2. Here NH2 is there, therefore it is called amine, and it will releases gas. Which gas? Hydrogen gas. Here 8 times of hydrogen are removed, actually 2 are there, right. Here before reaction 3 hydrogen are there, here how many are there? 2. Means how many hydrogens are removed? 1. How many times removed? X times. 1 hydrogen, it can be written as half H2, means it is releasing which gas? Dihydrogen gas. These all are the reactions or the chemical properties of the alkali metals. Now just check what we have discussed today. Here we have started all are finished. Reaction with air over, water over, dihydrogen over, halogens over, alkali metals over, ammonia. Reaction with air. When alkali metals reacts with air, it can form monoxide, peroxide, superoxide. If the oxidation number of oxygen is -2, monoxide, -1, peroxide, -1/2, superoxide. Lithium forms only monoxide, right. Sodium can form both monoxide and peroxide. Here peroxide I wrote. Now potassium, rubidium, cesium, when reacts with the air, it can form monoxide, peroxide, superoxides, right. That over. Next we have discussed the second one. Is reaction with water. Here it is. When alkali metal reacts with water, water means what? Here H2O means what? OH minus is there and H plus is there. Here alkali metals, after losing one electron, M plus OH minus combines to form MOH, that is corresponding hydroxide, and releases hydrogen gas, H2 gas. That is only I wrote. When alkali metals reacts with the water, they form the corresponding hydroxides and releases the dihydrogen gas, right. Second one also over. Third one is reaction with dihydrogen. When alkali metals react with the dihydrogen, they form hydrides, that is group 1 elements. When alkali metals reacts with the, right, or when group 1 elements they reacts with the dihydrogen to form the hydrides, which are ionic in nature, or ionic hydrides. Here the oxidation state or number of hydrogen is -1, that already discussed. Next the third one is, here I wrote few examples. Third one is reaction with, fourth one is reaction with halogens. That is, here it is. When dihydrogen reacts with the halogens to form corresponding halide. If the if you use the chlorine, chloride is formed. If you use the bromine, bromide is formed. If you use the fluorine, bromide, right, fluoride is formed. In this way, alkali metals react with the halogens to form the corresponding halides. That is only I wrote here. When alkali metals react with the halides to form the corresponding halides. Few examples I've seen, right. Here in the second reaction, right, here fifth chemical property, that is reducing nature of alkali metals. Just observe second one. Here alkali metal which is present in the gaseous state loses one electron. Loss of electron means oxidation. The one itself undergoes into the oxidation is called as what? Reducing agent. Means it is undergoing into the oxidation, therefore it is called as what? Reducing agent. This is called reducing nature of alkali metals. Over. The last one is reaction with ammonia. When it reacts with the ammonia, first complex is formed. That complex further undergoes into the reaction and forms the amines and releases the dihydrogen gas. These are the few chemical properties of the alkali metals. We will stop here only. We will discuss in the next class. Thank you.